Today we're talking about compound inequalities. Your learning target for today is I can solve a compound inequality. First of all, let's define what that means. A compound inequality consists of two inequalities joined by the word and or. To solve a compound inequality, you must solve each part of the inequality. Here's an example, or two examples, of what a compound inequality looks like. X is greater than negative 2 and x is less than 5 is a compound inequality joined with the word and. X is less than negative 3 or x is greater than 8 is also a compound inequality, but this one is using the word or. So first let's see what we mean by the compound inequality with an and. So if you were to look at the graph of a compound inequality that contains and, that actually is the intersection of the solution sets of the two inequalities. So I'll show you what I mean. If we graph x is greater than negative 2, so remember that's an open circle and we're going to the right. And now I'm going to graph x is less than 5. So that's an open circle going to the left. The intersection is the overlapping part, the part of the graph that was gone over twice. So the overlapping part would be this part in between negative 2 and 5. Notice we're still going to have open circles, but it's the part that's in between, the part that was shaded on the line twice, and that's the graph of the compound inequality. X is greater than negative 2 and x is less than 5. Now there's a fancier way to write compound inequalities that are joined with the word and you can actually write it in one statement. If you think about this one, the number we're going to call x is in between negative 2 and 5. So we can write this actually as one statement. Notice I'm not using the word and, but it still means this. X is greater than negative 2 and x is less than 5. The graph of a compound inequality containing or is the union of the solution sets of the two inequalities. And the union means we're going to unite the two different sets together. So if we have x is less than negative 3, so I'm going to put an open circle, shade to the left. My next statement is x is greater than 8. So our union for the or is going to be uniting these two together. So we end up with this piece combined with this piece. And that's my graph of the compound inequality if it contains an or. And it tends to look like this, where it's where you have your two different values marked and then the graph is split going out both directions. There is no fancy way to combine that and leave out the word or. So when you have an or statement, this type of compound inequality, you will always see the word or. So on this one, we're going to solve the compound inequality. Now you want to try and look at it and recognize, would this be an and or an or? And in this case, it's an and it's written in kind of that fancy way. So we need to solve each part. Now when it's an and problem, it's kind of nice because we can actually do it both sides at the same time. I want to get y by itself, so I need to add 2. Well, then I need to add 2 to each of these sides of the inequality. So now I have 12 less than or equal to 3y less than 21. I want to get y by itself, so I need to undo multiplying by 3, so I divide by 3. Have to do it to all the sides, both sides of the inequality. So the 3's cancel. I'm left with 4 is less than or equal to y is less than or equal to 7. That's my solution. When I graph this on a number line, I'm going to place a 4 and a 7. This time I'm going to fill in the circles for both. And remember that the and, I want the number is in between 4 and 7, so I'm going to shade in between 4 and 7. Now, interval notation, the left side is a 4, and since we're including it, we use the bracket, and the right side is a 7. So this is the way I can write my solution in interval notation. Why don't you go ahead and try this problem? So pause the video, try the problem, and then come back to it when you have an answer. Okay, so on this one, I'm going to subtract 6. We end up with 3 less than 3t less than 9. Now I'm going to divide each part by 3. So we get 1 less than t less than 3. Remember, that means my solution is in between 1 and 3, this time not including those endpoints. When I write it in interval notation, I'm not including the endpoint, so it's parentheses. And it looks like this for my solution set. Now you might look at that and say, well, how do I know it's not an ordered pair, like when you plot the x-coordinates 1 and the y-coordinates 3? Well, you'd know that because of the context that the problem is in. So when you're doing this type of problem and you see this answer, then you know that that's the solution set where your solution is in between 1 and 3, but not including the 1 and 3. Now we have an OR problem. So kind of picture in your mind what you expect that number line to look like. So we're going to solve each part. So I'm going to subtract 3 from each side. I get x is less than -1. And on this side, now you can either think of it as multiplying both sides by -1 or dividing both sides by -1. Either way, you have to remember to flip the inequality. So we're going to get x is greater than or equal to 4. Remember, this is an OR, and that is part of your answer. So when you write out your answer, you must include the word OR. Then for our number line, we're going to have less than -1. And remember, for the OR statement, we are doing the union, so we're combining these two pieces together, and we have greater than or equal to 4. So this is how I draw my number line, and again, remember, I have to write the word OR as part of my solution. Now, if you were going to do this with interval notation, you have to use our infinity and negative infinity part. Remember, negative infinity's down here, infinity's here. So we'd have negative infinity to -1, or, oops, wrong symbol. Need a bracket here, 4 to infinity. Okay, so that would be the interval notation. Can't put it together. Still have to have the word OR. Why don't you try this one? And again, pause the video, come back to it when you've had a chance to do the problem. So on this, we're going to add 3 to both sides. I get y is greater than 4, or subtract 2, I get y is less than -1. So I'm going to plot those. We have greater than 4 or less than -1. And this is my solution because I have to use the word OR. Here is my number line graph.